Hi guys, happy Monday afternoon. Let's get into some math here, so hopefully you can get done with your homework and get on to whatever it is you want to do tonight. So we are working on rates still, and we used to be trying to figure out if speed is what we're trying to figure out. We used to, in the last chapter, we were trying to figure out if speed is what they're looking for, then you do distance over time. And now we're actually switching that around and we're doing if time is what they're looking for, then you just go distance over speed. So essentially what we did is we just swapped these and we said if time is what you're looking for, then you take the speed and put it where the time was, but distance is still on the top. So we'll talk a little bit more about that later, but let's do a couple of our guided practice problems. So if you turn to page 184 in your textbook and get your composition book out and a pencil so we can walk through these problems, that would be great. So it says Lucas ran round a field at a speed of 8 meters per second. How long did he take to run a distance of 96 meters? So they're saying if he ran 8 meters in 1 second per second, how long would it take him to run 96 meters? So they're asking you a time. So just like our triangle down here, if they're asking us a time, we take the distance, which would be his 8 meters, and divide it by the speed. And his speed would be 8 meters per second. So what we do is method 1 that we use, depending on which one works best for you. We're going to work through both of them here. 8 meters in 1 second. So we would take 96 meters and we would divide it by 8, which would equal 12. So it said it would take him 12 seconds to run 96 meters. So just like our formula down here says, we took the distance, we divided it by the speed, and it would equal the time. Our method number 2 is just you take the time, the distance, it's essentially the same thing. 96 divided by 8 equals 12, and it took him 12 seconds to run 96 meters. So hopefully this formula here makes sense to you. The problem that they're asking us to find is the time it took Lucas, and the information that they gave us to find that out was 8 meters and 1 second, and then they said now find it for 96 meters. So let's go down to problem number 6 and have you guys go ahead and do that one on your own using this formula right here. If we're asked to find the time, then you just do distance divided by speed. So try that using both methods. Remember, we want to, whether you know what method works for you or not, I want you to try both at first, because sometimes you'll be surprised that actually now that I did that one, the other one does work. And so we're going to try both methods on number 6. So pause the video and do guided practice problem number 6 on page 124. Okay, we're back. Hopefully you got problem number 6 done. And now we're going to move on to finding our average speed. And if you notice, we have our little yellow box around this, which means it's one of our vocab words. If you remember, we went back to the first of the chapter. Sorry, I'm trying to find it here. And on page 168, it had a yellow circle for average speed. And so we're going to go over here and write average speed down in our composition book for our vocabulary, and I'll be looking for that when I look at your notes tomorrow. So find the average speed to solve a real-world problem. The speed that an object is traveling over a distance may not be the same all the time. So it might increase its speed. If you're traveling over to Seattle, you might increase your speed at certain points in the road and decrease your speed. For example, a bicycle might speed up or slow down as it travels between 2 points over a given amount of time. You can use an average speed to describe how fast the bicycle is traveling. So look at this example. So for your definition, The average speed would be how fast a bicycle is traveling, or how fast an object is traveling, right here on the first line, over a distance. So if you take the whole distance and you average out, remember an average is where you take all of the ages or all of the speeds or all of the items and you add them all up and then divide it by however many items you're adding up. So the average speed would taking all your speeds over that distance, adding them up, and then dividing them by that many speeds to make the average. So our average speed would be the speed of an object traveling over a distance. So let's go ahead and figure that out for post A and post B. They are 9 meters apart. Post B and post C are 21 meters apart. A bicycle travels from post A to post B in 2 seconds. Then it travels from post B to post C in 3 seconds. Find the average speed of the bicycle for the distance from post A to post C. So here's a picture. They wrote it visually for us. Here's A, and remember it said up here post A and B are 9 meters apart. So here's our 9 meters between post A and post B. Then post B and post C, here to here, is 21 meters. So they wrote 21 meters. And then it tells us also the information it gives us down here is a bicycle travels from post A to post B in 2 seconds. So that's what this 2S is. It traveled 9 meters in 2 seconds, and then from post B to post C in 3 seconds. So this 3S is that 21 meters in 3 seconds. So he apparently was going much faster than over here. So the speed between post A and post B is different from the speed between post B and post C. The average speed is the distance traveled per unit time. So let's go move our book down a little bit here. And it's giving us a formula right down here. It says your average speed is, just like we talked about, the total distance traveled divided by the total time. So we add up all the distances and then we divide it by the total time. So the total distance from post A all the way passing post B till you get to post C would be 9, because between A and B is 9 meters. Between B and C is 21 meters. So we do 9 plus 21 would equal 30 meters. So 30 is the total distance traveled. Then the total time to travel from post A, go all the way past post B and get to post C, it took 2 seconds to go from A to B and 3 seconds to go from B to C. So if we add our 2 seconds and our 3 seconds, it equals 5 seconds. So now we have a formula that we can use for our total distance traveled and a total time. So we just plug in those numbers. Our total distance traveled was 30. Our total time was 5 seconds. So we do 30 over 5, or 30 divided by 5. If we put 5 into 30, it comes up with 6 meters. And remember, this slash is per meters per second, 6 meters per second. So the average speed of the bicycle is 6 meters per second. So if you take when it's not going fast and when it's going fast and you even those all out, the average speed is 6 meters per second. So if you wouldn't mind turning over to page 176 to number 7, the guided practice problem, and doing that on your own. It gives it to you visually here, and then using this formula, finding the total distance traveled by adding all of those up, and the total time traveled by adding up the time, and then doing your division to come out with the total average speed. So if you could do number 7 and number 8, that would be wonderful, and then we will go over those in class tomorrow. So just to clarify, we are going to start on page 170, hold on, let me see here, 174. page 174, and we're going to do practice problems or guided practice problems. And by the time you come to class tomorrow, you should have done number 6, number 7, and number 8, and also written your vocab word with a definition that we went over in this video. So if you could do these 3 problems and write your vocab word with a definition, and we will go over the rest tomorrow. Thanks so much. Have a great Monday night, and we will see you guys tomorrow.